Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to continue talking about all the factoring techniques with which you need to be familiar in order to be successful on the Armed Services Vocational Aptitude Battery, notably the Mathematics Knowledge Subtest. More specifically, we're going to talk about factoring quadratics when the leading coefficient is not 1 today. In case it's helpful, uh, I'm going to post a link to this factoring guide in the description of this video. As I go through this series on factoring, you may want to pull this up and look at it as I work out some of these practice problems. All that said, let's go ahead and get started with today's video. Okay, so before we get started with number 1, I quickly want to mention that we're still dealing with quadratic equations. More specifically, everything we're going to deal with is going to be of this form: ax squared plus bx plus c. And whereas in yesterday's video, this leading coefficient, namely a, was 1, all the variables for a, all the leading coefficients today are going to be something other than 1. That said, I also want to point out that all quadratic equations, including the ones I worked on yesterday, as well as the ones we're going to factor today, can all be solved using the quadratic formula. Remember, that's negative b plus or minus the square root of b squared minus 4ac all over 2a. That is, you can simply identify your a, b, and c, plug those into the quadratic formula, and solve accordingly. As I mentioned in yesterday's video, the reason this isn't used to solve these types of quadratics is it's very tedious and time-consuming. As you'll see in just a minute, it takes me about 30 seconds to factor these using the technique I'm going to show you today, whereas it would take probably 2 minutes to use the quadratic formula. In addition to being more efficient, you're also less likely to make a mistake if you just use this factoring technique to solve these quadratics. Finally, I want to mention that on the ASVAB, you're probably not going to be told to factor. Rather, for number 1, for example, you'll be told to solve for m instead. And in light of that, you have to recognize, 1, that this is a quadratic equation. And in light of that, you can either use the quadratic formula or this factoring technique we're going to talk about today to solve for the variable m. So with all that said, let's go ahead and talk about how we're actually going to solve these using a factoring technique. If you're looking in the factoring guide, I'm actually going to be using what's called the Australian method to factor everything in today's video. And instead of going through the Australian method step by step, which can be a little confusing, I'm simply going to show you how to use it. And once you get through 2 or 3 of these, it should click. And instead of being frightened by quadratics where the leading coefficient's not 1, these actually become very, very easy to do. And again, if at any point you get stuck on factoring any of these, always revert back to the quadratic formula. When I took the ASVAB, I remember there was one I just couldn't factor for whatever reason, and the quadratic formula helped me solve it. So let's get started with the Australian method. The Australian method says first multiply a times c. So we're going to go ahead and do that. Again, a times c. Again, here's our a, and here is our c. So in this case, a times c is going to be 7 times negative 1, or negative 7. Okay. The next step says identify your b. So b in this case is going to be simply 6. Let's write that over here. And then it says find 2 integers that multiply to a and c, but add to b. So let's go ahead and see what that looks like. Again, we're looking for 2 factors of negative 7 that add to positive 6. Well, if we do positive 7 and negative 1, Positive 7 times negative 1 is negative 7. And these, of course, sum to positive 6. Again, 7 plus negative 1 is positive 6. So we've identified two factors that meet those requirements, namely that multiply to AC and add up to B. And then the Australian method says take those two new factors and plug them in this middle term. So instead of having 6m, we're going to have plus 7m minus 1m. So let's go ahead and do that. Again, according to the Australian method, we rewrite this original equation using these two factors in place of this middle term. So we have 7m squared. And since we're going to be factoring by grouping in just a minute, I'm going to arrange this such that like terms are close to each other. So I'm going to put plus 7m here, minus 1m here, and then minus 1 here. So as you can see, I simply got rid of that 6m and replaced it with the two factors I found using the Australian method. And now the Australian method says factor by grouping. Okay, so in case you haven't seen this in a while, you simply imagine that this equation is split in half, and you're going to factor common factors from this front half as well as this back half. So from these first two terms, I know I can pull out a 7m, and in doing so, that leaves me with m plus 1. And again, from this second pair of terms, I know I can pull out a negative 1. And that's going to leave me with m plus 1. And finally, the Australian method says your new this is factored, and all you have to do is combine the 7m and the negative 1. And then this pair that repeats is your second factor, so that looks like this. 7m minus 1 and m plus 1. And just like that, we've factored this quadratic equation where the leading coefficient's not 1. Again, on the ASVAB, you'll be told to, rather than just factor, to solve. So as we did yesterday when we got to this point, we would simply break these two apart and set them equal to 0. So we would have 7m minus 1 equals 0, as well as m plus 1 equals 0. And we would just solve for m accordingly. For this one, we'll add 1 to both sides first. Let me go down a little bit so we have more space. Again, negative 1 plus 1 crosses out. This leaves us with 7m equals 1. Again, we're trying to get m by itself, so we're going to divide both sides by 7 as our next step. This crosses out, leaving us with m equals 1 over 7. Okay, this one's very simple. It's going to take one step to solve. We're going to subtract 1 from both sides. 1 minus 1 is nothing, so this leaves us with m equals 0 minus 1, which is negative 1. So by using the Australian method, we've solved for the variable m. Specifically, we found two real solutions, notably 1/7 and negative 1. Okay, so I like the Australian method. It's very quick. It's very easy. And once you get the hang of it, you'll see that you can solve any of these trinomials or quadratic equations where the leading coefficient's not 1 in a matter of seconds. Again, I did this one very slowly just so you can get the hang of it. After number 2, I would say go ahead and start pausing this video. Try to work out these on your own and see if you and I come up with the same answer. But again, usually the first time you do something, it's not that clear. So let's go ahead and use the Australian method one more time to solve number 2. Again, the first step in the Australian method says find a times c. Again, a times c, we know 3 is going to be our a, and similarly, we know 7 is going to be our c. 3 times 7 is simply 21. Identify your b. b, as we can see, is right here. It's negative 10. Then it says find two factors of a and c that add up to b. So again, we're looking for two factors of 21 that add up to -10. What about -7 and -3? Again, -7 times -3 is +21. And these do, in fact, sum to -10. Again, -3 plus -7 is, in fact, -10. So these are the two factors we're going to use to rewrite this equation. More specifically, we're going to take these two factors and plug them in for this 10k. We're going to substitute them in for 10k. And we're going to do so in such a way that's going to make factoring by grouping very easy. So as you can see, I have a 3k here and a 7 here. So I'm going to try to rewrite this equation such that the 3's with the 3 and the 7's with the 7. So let's go ahead and do that. Again, the next step in the Australian method is to substitute those two new factors in for the middle variable, or the middle factor. So we have 3k squared. Again, I'm going to try to group similar things, minus 3k minus 7k plus 7. And then it says factor the new equation via grouping. And again, if it's helpful, you can imagine there's an imaginary line right there splitting this equation into two parts. And if we just look at these first two terms, notably 3k squared minus 3k, we should be able to recognize that we can pull out a 3k pretty easily, which will leave us with k minus 3. And then if we look at this second pair of terms, namely -7k plus 7, we should also recognize that we can pull out, oh, I made a mistake there. This would be k minus 1. Sorry about that. And if we look at this second pair of terms, we can see that we should be able to pull out a -7, which will leave us with k minus 1. And then you simply combine the 3k minus 7 and the k minus 1 as your solution. So 3k minus 7 and k minus 1. And just like that, using the Australian method, which involves some mental math as well as some very simple factoring by grouping, you've solved this one. Again, on the ASVAB, you're going to be told, instead of to factor this, to solve for k. So let's say we were asked to solve for k. Again, we would just break these apart and set them equal to 0 and then solve for k. So let's go ahead and do that. 3k minus 7 equals 0. K minus 1 equals 0. To get k by itself, in this one, we're going to add 7 to both sides as our first step. Minus 7 plus 7 crosses out. This leaves us with 3k equals 0 plus 7, which is 7. Again, we're going to divide both sides by 3. This is going to cross out, leaving us with k equals 7 over 3. And this one's much simpler. As we can see, we're going to add 1 to both sides to get k by itself. This is going to cross out, leaving us with k equals 0 plus 1, or just 1. And just like that, using the Australian method, we were able to solve for the variable k. As we can see, there's two real solutions, and that's pretty much it. So let's go ahead and do a couple more, just so you get the hang of the Australian method, and then that will be it for today's video. So again, if you want, you can pause the video, try these on your own, and see how you like using the Australian method. Again, I really think these are very easy to factor using the method, so that's why I'm creating a video about it. So again, according to the Australian method, you first want to identify a times c. Again, this is going to be our a, and this is going to be our c. Again, I'm getting those from this, in case it's not clear. Again, this is the form in which all quadratic equations are written. As you can see, we have a, b, and c. Again, a times c is going to be 3 times 20, which is going to be 60. And then, according to the Australian method, you want to identify your b as well. B in this case, we can see is going to be negative 16. So in other words, we're looking for two factors of 60 that add up to negative 16. And this one's not that straightforward because there are a lot of different factors of 60. So if you got stuck here, just bear in mind that sometimes you have to look for multiple factors before you find the right one. But that said, we should be able to tell that negative 10 times negative 6 does in fact multiply to positive 60, and as much as a negative 10 times a negative 6 is positive 60. And then negative 10 plus negative 6 also adds to negative 16. So these are, in fact, the factors that are going to work. And then according to the next step in the Australian method, we rewrite this middle term, notably b, with these two terms in such a way that it's factoring by grouping is going to be very easy and straightforward. As you can see, I have a 3n squared here. That's going to be easy to group with a 6. And for c, I have a 20, which I can easily group with 10. So that's how I'm going to rewrite this middle term. I'm going to do more specifically 3n squared minus 6n minus 10n plus 20. And again, if it's helpful, just imagine there's a line breaking this equation into two equal parts. So now I'm looking at these first two terms, notably 3n squared minus 6n. I'm trying to factor out some common terms. As you can see, we can easily factor out a 3n, which will leave us with n minus 2. And now we're looking at this second pair of terms, and as you can see, we can factor out a negative 10 pretty easily, which will leave us with n minus 2. And now we're just going to combine the 3n minus 10 and the n minus 2 to fully factor this one. So we have 3n minus 10 and n minus 2. And using the Australian method and 1, 2, 3, 4 steps, we've gone ahead and fully factored this one. Again, on the ASVAB, instead of being told to factor this, you'll be asked to solve for n, which should prompt you to either use the quadratic formula or factor this using the Australian method. But that said, once you get to this point, it's just a matter of setting both of these equal to 0. Let me fix that real quick. Then solving for n accordingly. Again, for this first one, it's going to take 2 steps. The first step to get n by itself is going to be to add 10 to both sides. 10 minus 10 plus 10 is 0, so this leaves us with 3n equals 0 plus 10, which is 10. We're going to divide 3 to both sides. This crosses out, leaving us with n equals 10 over 3. And this one's much simpler. It's going to take 1 step to solve. We're going to add 2 to both sides. This crosses out, leaving us with n equals 2. And just like that, we went ahead and solved this one using the Australian method. All right, for number 4, we have 2r squared plus 7r minus 30. According to the first step in the Australian method, we first want to identify a times c, which is going to be 2, which is a, times negative 30, which is c. 2 times negative 30, of course, is negative 60. And we also, in addition, want to identify our b, which is going to be positive 7. And now we're looking for two factors of negative 60 that sum or add to positive 7. And again, when I say two factors, I mean two things that multiply together to give you negative 60. If we think about this for a minute, we'll see that 12 times negative 5 does in fact multiply to negative 60. And 12 plus negative 5 also sums to 7. So those are the two factors we're going to go with. More specifically, we're going to take these two factors and use them to rewrite b, notably 7r. And since we're running out of space, I'm going to go ahead and do that down here. Again, 2r squared. We're going to rewrite 7r with these two terms. And again, we want to do so in such a way that's going to make factoring by grouping easy. I know I can pair 5 with 30 pretty easily, which leaves me with pairing 12 with 2. So again, I'm going to write in plus 12r as well as negative 5r in place of 7r. And of course, we're just going to tack on the minus 30 there. Now we're going to factor this by grouping, which means we're going to imagine that there's a line splitting this equation into two parts. And to start, I'm going to look at 2r squared plus 12r and try to factor out a common term. In this case, I'm going to factor out more specifically a 2r, which is going to leave me with r plus 6 over here. And then I want to factor out a common term from this next pair, notably 5r minus 30. That's going to give me this same term in parentheses, notably r plus 6. And if I if I factor out a negative 5, and let me rewrite that real quick. My pen's acting up a little bit here. If I factor out a negative 5, you can see that's going to leave me with r plus 6 in the parentheses. And now I just combine 2r and negative 5, and my other factor is going to be r plus 6, so it's going to look like this. 2r minus 5, r plus 6. So if we were told just to factor this, we would be done at this point. That said, on the ASVAB, instead of being told to factor this, you're going to be asked to solve for r, which means you're going to have to break these apart and set them each equal to 0 and solve for r. So let's go ahead and do that. We have 2r minus 5. Let's let that be equal to 0. And r plus 6. Let's let that equal to 0. Again, for this one, we want to get r by itself. So the first thing we're going to do is add 5 to both sides. Negative 5 plus 5 crosses out. This leaves you with 2r equals 0 plus 5, or just 5. Now we're going to divide both sides by 2 to get r by itself. This crosses out, leaving you with r equals 5 over 2. Again, to get r by itself in this equation, we're going to subtract 6 from both sides, which is going to cross out here, leaving you with r equals negative 6. So our two real solutions for this one are going to be 5 over 2 and negative 6. Okay, so let's do one more. And at this point, I think you probably have the hang of this. Again, according to the Australian method, the first thing to do is multiply a times c. And again, we're pulling that from this quadratic equation, which is of this form, ax squared plus bx plus c. So we can see 5 is going to be our a, and 8 is going to be our c. So a times c, in other words, is going to be 5 times 8, which is going to be 40. Our b, as we can see, is going to be negative 14, so let's plug that in. And again, at this point, we're looking for two factors of 40 that sum to negative 14. If we do negative 10 and negative 4, we can see negative 10 times negative 4 is positive 40. And of course, negative 10 plus negative 4 is negative 14. So those two factors do in fact work. According to the Australian method, what you want to do next is take these two factors and write them in place of b in the middle in this equation. So let's see what that's going to look like. And again, we want to rewrite this equation such that factoring by grouping is going to be easy in our next step. As you can see, I have a 5 here. 5 pairs well with 10. And I have an 8 here. 8 pairs well with 4. So that's the order in which I'm going to rewrite this middle term b. That is, I'm going to put negative 10x here, negative 4x next, plus 8. And again, now we're just factoring by grouping, which means we imagine there's a line right here splitting this equation into two halves. And if we look at this first half by itself, we can see that I can factor out a common value, a common factor of 5x, which will leave me with x minus 2 here. And again, now I want to factor out a factor that's going to leave me x minus 2 into parentheses from this pair. So I'm going to factor out a negative 4, which is going to leave me with x minus 2. And now you combine 5x minus 4 as well as x minus 2, which are going to be your factors. So this is going to be 5x minus 4 as one factor, one solution, and x minus 2 as the other solution. Again, on the ASVAB, more often than not, it's going to say solve for x. And you're going to have to realize that you have to use either a factoring technique or the quadratic formula to solve this one. And either way, you're going to get to the point where you have to split these apart and set them equal to 0. So we're going to set this 5x minus 4 equal to 0, as well as x minus 2 to 0. And then we're going to solve for x accordingly. For this one, we're going to add 4 to both sides, which is going to cross out here, leaving you with 5x equals 4. Then we're going to divide both sides by 5, and that's going to cross out, leaving you with x equals 4 over 5 as one solution. And then for this one, we're going to add 2 to both sides. Negative 2 plus 2 is nothing, and that's going to leave you with x equals 0 plus 2, which is 2. So as you can see, using the Australian method, we were able to solve for x. More specifically, we can tell that this quadratic equation has two real solutions, notably 4/5 and 2. Okay, so that's all I have for you in this video. I hope you found it helpful. Again, if I ever see a problem in regard to factoring a quadratic on any standardized test, I really don't panic too much because I know the Australian method's going to make it very easy to solve. If it's leading coefficients 1, I can also factor it very quickly. Otherwise, I can always revert back to using the quadratic formula to get the solutions. So all that said, feel free to leave some feedback in the comment section below. But on that note, I'm going to go ahead and catch you loose. Konnichiwa.